Hello and welcome to today's class. So we are going to continue with linear equations, but in this particular class, we're going to focus on linear equation that involves two unknown variables. Okay, so in the previous class, we only did linear equations involving single or one unknown variable, and so today's class is going to involve one that involves two unknown variables. These such equations are usually known and usually called simultaneous equations. They're usually called, simultaneous equations. So the example that I have here is a demonstration of a simultaneous equation. Okay, it is a linear equation with two unknown variables, that is a and b. So we have equation 1 as a plus b equals to 7, and equation 2 as a minus b equals to 5. And so we are supposed to solve for a and b. All right, we're supposed to solve for the two unknowns. We're supposed to get the value of two unknowns in this particular simultaneous equation. So there are two methods that usually this is used. This is approached with, and that is usually elimination method and substitution method. So for this particular video, we are only going to focus on elimination method. Okay, we are going to focus on elimination method. So with elimination method, the focus is usually to get rid of one unknown so that we only have one. Is usually to get rid of one unknown so that we are only dealing with a single unknown variable, which we can then solve. And after we've solved, we come back and solve for the other eliminated variable. Okay, now let's solve this particular example here and demonstrate what I'm talking about here. So elimination method requires us to know two important rules. Okay, elimination method requires us to know two important rules. That whenever we're having same signs, okay, for the variable we want to eliminate, whenever we're having same signs, we will subtract. Okay, when you're having same signs, we will subtract. So I'm going to put it as a note here. Okay, and I'm going to have it in bracket as S, and that is to mean that same sign subtract. Okay, same, when the signs are similar for a variable that you want to eliminate, you subtract. That is one. And then two, the other rule is that usually if they are different signs, you add. Okay, so different signs, add, DSA. All right, so we're going to come to this particular equation, and I'm going to say that I'm going to propose that we eliminate A. Okay, we're going to eliminate A and then find the value of B. All right, in the process of solving this simultaneous equation. Now I want you to look at A. All right, A in the first equation is a positive variable. Okay, it is positive A, and A in the second equation is also a positive variable. Okay, it is positive A, and so we're going to use the first golden rule, that is same sign subtract. Okay, while you're subtracting, again, you always want to make sure that they have same coefficients. Okay, they have not really same coefficients, but if the coefficients are not the same, you find the LCM, and basically you'll see how we approach it in the various examples that we're going to do. So in this particular case, because the coefficient of A is 1 and the coefficient of A in the second equation is 1, we're basically going to subtract. And so notice how by subtracting we will eliminate for A. Okay, by subtracting we will eliminate for A. So we are going to take A minus A. All right, we're going to take A minus A. So A minus A is going to give us 0. Okay, I can just have it written there as 0. So that already on its own has eliminated the variable a for us. That is why we are calling this, elimination method. All right. So we no longer have variable a, right? Because we've taken a minus a, and a minus a has basically given us 0. So we've eliminated that particular variable. That's why it's called elimination method. All right. And so we're going to then subtract, the other variables. Okay. So we're going to take b minus negative b. Remember, we are using the golden rule as a same sign subtract. Okay, and we are subtracting equation 1 and equation 2. Right, that is what we are subtracting here. We're subtracting what? Equation 1 and equation 2. So same sign subtract. A minus a giving us 0, eliminating a in the process. Remember, that is what you are focusing on eliminating. So right now we're going to take b, positive b, minus negative b. Okay, so basically that is going to give us 2b. All right, it's going to be 2 minus b. So positive times positive giving us, all right, so that's going to give us plus 2b equals to 7 minus 5, basically 7 minus 5. Okay, remember, we're subtracting these two equations. Okay, all right, and it's because of the golden rule, same sign subtract. So 7 minus 5 will give us 2. All right, so to solve for b, we are basically going to have both sides divided by 2. Okay, divide both sides by 2. All right, so when you divide both sides by 2, then the value of b will be equal to 1. So we've solved for b. However, we have not solved for a. Remember, a was the value that we eliminated. All right, so we know the value of b, but we are supposed to solve this simultaneous equation by finding the value of a and b as well. All right, for us to find the value of a, now that we have the value of b, we are going to pick either of the equations, either 1 or equation 2, and just substitute for the value of b. All right, so I'm going to go with equation 1, all right, which is a plus b equals to 7. All right, and so knowing that the value of b equals to 1, we're going to basically have a plus 1 equals to 7. And so, having the variables on one side of the equation and the numbers on the other side of the equation, we're basically going to have a being equal to 1 taken to the right hand side of the equation is going to give us 7 minus 1. And so a will be equal to 6. So this is it. All right, this will be how we will have solved this particular problem using elimination method. Okay, why? Because the value of a we found now to be equal to 6, and the value of b we found earlier on to be equal to 1. And that will be the solution to this particular problem. So we are solving it. We've solved it using elimination method, and the golden rule was, in this particular case, same sign subtract. Okay, and that is the one that we used to solve this simple problem. Why don't we handle another example just to get you a little comfortable with this kind of equation? All right, so let us handle example 2 of linear simultaneous equations and see how what solutions we come up with. So we're going to use the same method, elimination method. All right, we're going to use elimination method to try and solve this simultaneous equation. Remember, we are handling equations with two unknowns in this particular class today, and so that gives us a very special scenario called very, very special set of equation called linear simultaneous equations. All right, so when you're using elimination method, remember the golden rules. All right, the golden rule is same sign subtract and different signs add. Okay, when the variable you're trying to eliminate are of the same sign, you subtract, same sign subtract, and if they are of different signs, you add. So in this particular example, that is equation 1 and equation 2, where we are supposed to solve for the value of a and b. We will solve it. We'll start solving it by first eliminating for the value of b. All right, We first solve it by first eliminating for the value of b. Remember in the previous example, we had a, and they were of same signs, and so we just kind of subtracted. And so we are choosing b because I want you to note in a equation 1, we have b having a positive coefficient, and in equation 2, b has a negative coefficient, okay? So it is plus 5 and minus 5. So those are different signs. All right, so what do we do to different signs? When they are of different signs, we add. Different signs add. So we're going to add equation 1 and equation 2 together. So basically that's going to give us 3a plus 6a, and that will be 9a. All right, we are adding them, and so that's going to be 3a plus 6a, giving us 9a. And then b, for the b variable, we're going to have 5b plus negative 5b. Remember, we are adding the different signs, and so basically that is close to having 5 minus 5. Okay, so 5b minus 5b basically will give us 0. Okay, so and we are going to have it there as 0. Note, we are doing different signs and adding them. Okay, the coefficients of b were of different signs, so we're supposed to add. So basically, when we add 5b minus 5b, we get 0. And so we're going to continue by taking 20 plus 12. Why? Because we are adding equation 1 and 2. So 20 plus 12 is going to give us 32. All right, so this one here basically will simplify to 9a equals to 32, which is a very simplified version of this equation that we can then go ahead and solve. All right, so basically to find the value of a, we are going to divide both sides by 9. All right, and so it's going to be a equals to 32 all over 9, which is basically 3 and which is 3 and yes, which is 3 and 5 out of 9, which is 3 and 5 out of 9. All right, or a recurring decimal point of 3.555555 and all that. So anyways, so that is the value of a. That is the value of a. So for us to find the value of b, we are basically going to have to substitute whatever we have as the value of a into either equation 1 or equation 2. All right, so I'm basically going to use equation 1. So equation 1 here is 3a plus 5b equals to 20. All right, so I'm going to substitute the value of a, which is 32 all over 9, into this particular equation. That is our equation 1. All right, so but that's going to be 3 into 32 all over 9 plus 5b equals to 20. Plus 5b equals to 20. All right, so basically that's going to leave us with 5b being equal to 20. Okay, we are having the variables on one side of the equation and, all right, the numbers on the other side of the equation. So that's going to be 5b. And so when we take this on the other end, we're going to have 3 into 32 all over 9. And so when you simplify this, you will note that the value of b will be, so when you simplify this, you'll note that the value of b will be 28 all over 15. So basically that will be it. It will be 28 over 15, yeah. So basically that will be the value of b in this particular problem. You can go try doing it yourself again, and just make sure that you understand everything, so that nothing is confusing to you. And so we're going to handle the last example, then call it our class. Awesome. So this is the last example. Then we will wind this class up. So we are having a simultaneous equation, 3x plus 4y equals to 18. As our first equation, and second equation being 5x plus 6y equals to 28. And so we are supposed to solve it. We're going to solve it using elimination method, okay? As this video is focused on that, okay? Elimination method. And so before we continue, I'm just going to refresh your mind. The golden rule of elimination method: same sign, subtract, and different signs add. All right, same sign, subtract, and different signs always add. So in this particular case, I want us to start by eliminating for x. Okay, eliminating the variable x. Okay, so basically I want you to note that the variable x has a positive coefficient in equation 1, and a positive coefficient that is 5 in equation 2. All right, so basically we are going to subtract them, so it's going to be same sign, subtract. Okay, now note and take notice that when we take 3x minus 5x, we won't get 0. And the reason why we are always subtracting is so that we eliminate the variable. And because we won't get 0 by subtracting these two coefficients of x directly, we are then going to alter the coefficients such that when we subtract them, we get 0. And so by altering the coefficient, we won't change the equation. We won't really change the value of anything. It will be the same. It will be the same equations, but with different variables or with different coefficients, which are still the same for these, which are still describing the same equation of these lines. Whether when you describe them respectively. All right. So basically what I mean is we are going, because we are focusing on eliminating x, we are going to find the LCM of 3 and 5. Okay, we're going to find the LCM of 3 and 5, and then rewrite the all simultaneous equation using the dividends of of dividing the LCM by these current coefficients. Okay, so the LCM of 3 and 5 happens to be 15. Okay, I'm just going to write it somewhere on the side there. Yeah, so the LCM of 3 and 5 happens to be 15. All right, that's okay. So what you're going to do, we are then going to take 15 divided by 3 for equation 1. 15 divided by 3, and whatever we get, we're going to multiply by every term in equation 1. So 15 divided by 3 will be 5. So that means that in equation 1, we will multiply every term by 5. And remember, the reason why we're doing this is so that we are having a situation where we can eliminate for the variable of x. Okay, that's the reason why we are doing this. And then we are going to take 15 divided by 5. All right, the coefficient of x in the second equation. So 15 divided by 5 is going to be 3. And so we're going to multiply every term in the second equation by 3. Remember, our goal is to have the variables of the coefficients of x such that when we subtract them, we eliminate the variable x. Okay, so basically this is going to be, we're going to expand. So this is for equation 1. We are going to expand for equation 1, then equation 2, of course. So that's going to be 5 times 3x. 5 times 3x is going to give us 15x. Okay, 5 times 3x is going to give us 15x. Then we are going to take 5 times 4y. All right, 5 times 4y, and that's going to give us 20y. All right, and then we're going to take 5 times 18. All right, and that's going to give us 90. Yes, and that's going to give us 90. So that will be it for equation 1. All right, so we've taken 5 times every term in equation 1, and so we're having 15 plus 20 being equal to 90. Now for the second equation, we're going to take 3 times every term as well. All right, and so when you take 3 times every term, it's going to be 3 times 5 giving us 15x. Okay, 3 times 5 giving us 15x, and then 3 times 6y, and that will give us 18y. All right, so 3 times 6y will give us 18y, and then finally we'll take 3 times 28, and that 3 times 28, and that will give us 84. Awesome. That will give us 84. So we have rewritten both equation 1 and equation 2 in a form where when we now subtract, all right, the coefficients of x, we will get rid of that variable. Right, that was the goal, and that is what we've achieved. So whenever you have a situation where when you add or when you subtract for the coefficients of the variable and it is not coming to 0, just find the LCM and do as we've done with this particular problem. Okay, all right. So now same signs subtract. So because we are focusing on eliminating for x, we are then going to have a situation, we're going to subtract equation 1 and equation 2. All right, so note that's going to be 15x minus 15x, and that will give us 0. So we've already eliminated that variable. Right, so we no longer have x. We won't have x in our equation. Right, so then we are then going to take 20 minus 18y, 20y minus 18y, and that will give us 2y. That's okay. Yeah, that's okay. And now for the last part, we're going to take 90 minus 84. Okay, 90 minus 84, and that will give us 6. All right, for our third equation, that will give us 6. So for us to solve for the value of y, basically we'll divide both sides. We'll divide both sides by 2. Okay, and so the value of y will be equal to 3. All right, the value of y will be equal to 3. All right, so that is y already solved. So we want to try and solve the value of x, which we had eliminated, right? Which we had eliminated. And remember, this method that we're using here is elimination method. And you get why? Because we are solving for y by eliminating for x. Right? Then after that, we can easily solve for, the other variable. So we're going to pick either equation 1 or 2 to solve for the value of x. So I'm going to go with equation 1. So equation 1 was 3x plus 4y being equal to 18, right? And we already know what the value of y is. The value of y is 3. So basically this is going to be 3x plus 4 into 3 being equal to 18. 4 times 3, that is, yeah. So note this will be 3x being equal to 18 minus 12. All right, so it will be 4 times 3, which is 12. And when you take the 12 on the other side, it will be, because it was a positive, it will be a negative. So that will be 8. So for us, okay, of course, this will simplify to 3x being equal to, is that 6? Yeah. So that will be 3x being equal to 6. Now, for us to find the value of x, we will divide both sides by 3. And so the value of x will be equal to 2. And so this will be the solutions to this particular linear simultaneous equation. So the value of x will be 2 and the value of y will be 3. I hope that was easy to understand. And if not, you can always reach me out in my email from the description, all right, of this video. Thank you and have a good one. See you in the next class.